Hey everyone. So today I got my friend Alpha again, and this time he actually cracked the top 5,000 on LeetCode. How you feeling about that?
Pretty good. Pretty good. I'm curious, like, I feel like now my progress is going to be kind of slow because, like, as you get higher, it's probably just going to be, like, going to slow down a lot. So I'm curious, like, I feel like if I do, like, double the questions, I might get, like, another 1,000 or two.
Yeah.
So, yeah,
And
see
then
how it goes. But yeah, I'm going to start doing contests this year
yeah,
and
we
see how
had
that goes as well.
somebody talking about contests, but don't worry, Alpha's gonna get on those contests. He's gonna get. I feel like your elo is gonna be really high, so that's why I'm excited to see you actually take on those contests and then drop videos on it because I'm trying to learn Q3s and Q4s and stuff by just like
Yep,
watching
yep.
your videos. But how are you feeling about system design?
Yeah, so I started studying it recently. Not the best at it, but I've been studying it a lot. So definitely like two or three times better than I used to be, but still a lot of room to
Nice.
grow there.
Yeah,
So
I see.
definitely nowhere near as good as I am at LeetCode, but yeah, I think if I do, some mocks and learn some more stuff, be a
Yeah,
lot better in like the next couple months. So
yeah,
yeah.
makes sense. Yeah, it's good that you're not just doing lead code, but then you're doing system design, and then you're doing the great front end. So you're learning pretty much everything.
Yeah. Plus you just get bored of doing like LeetCode questions every day. So yeah,
Yeah,
good
I
to have
mean you did like
variety.
5 yesterday, or 10. Holy,
Yeah.
you have a ton.
Yeah.
Okay, cool. Um, yeah, since we have a top 5,000 lead code user here, and he's very experienced with lead code. We're gonna run through a system design interview, and I'm gonna ask you to actually design lead code. How do you feel about that?
Feeling okay. I mean, yeah.
Yeah, you should know the features, but I mean, we're gonna do a system design mock interview, so of course we can't create that whole application in one go. So we're gonna limit this to around 50 minutes, and then yeah, and then so we're gonna make sure we pace through it because that's gonna be how long you have an interview. But yeah, so
Mhm.
it's gonna be important to prioritize core features, and yeah, let's focus on hitting all the functional requirements and stuff like that. I'll let you take the lead of the interview because you're probably interviewing for more senior roles. So I'll let you kind of like guide me through how you would think of designing this lead code question, and I probably will just jump in from now if I have any questions. But yeah, feel free to go ahead and design lead code.
All right, all right. So I guess we can get started with writing the functional requirements. Let me know if you can see my
Hmm.
text here.
Yeah,
Okay. So functional. And then I'm gonna write down what I think we want to have, and then you can let me know if there's anything else you'd like me to have. So I'm
yeah,
just
for
gonna
sure.
write down two or three.
Hmm.
So I guess the first thing is we want to have like some list of problems. And yeah, I'm gonna pretend like I don't know LeetCode that much because I don't want to just do the exact like LeetCode stuff because that doesn't seem realistic. So I'll just
Hmm.
like think of some random stuff. So yeah, basically want to have a list of problems where maybe someone can like type like a name of a problem or a partial name or whatever. We'll just call it search. And then can like filter by other stuff like difficulty,
Hmm.
type of problem, whatever other stuff, right? So
Hmm.
we'll have a search and then we'll have some like additional stuff they can like filter for. Does that seem pretty good?
Sure.
Okay. So then I guess the main part of it is when they click on the problem, we want to actually display a problem here. So display problem with problem statement to the user. Um, and we want to let them essentially type in code and submit it and then get a result.
Yeah.
So let them send us code and get a result. Yeah, I'm not going to worry about too much fancy stuff. Literally just like we'll say they run the code and then we'll just say like pass or not pass, something really simple. We're not going to have like a bunch of LeetCode features, just something as simple as that. Does that make sense?
Makes
So they
sense.
type
Yeah.
in the code, submit, yes or no. Okay.
Hmm.
Let's see what else we got here. Okay, and then yeah, I guess like display user profile so they can click on it. So like number of questions solved, uh, maybe like latest submissions,
Hmm.
things like that. Just like some generic user profile stuff where they can see like stuff about them. Yeah. So
Yep.
I think that's going to be the main stuff. Do you have anything else?
Let's see. List the problems. Displaying a problem. Yep. Sending code and getting a result. Displaying user profile. I think yeah. I think this is a good set of core functionalities. Maybe a fourth one is if we want we might be able to get to it, but I would be curious of how you design contests. But let's just add that for now, and if we get there, we get there.
Okay. So I'm just going to have it without it for now, but we can
Sure.
add it in if. Okay.
But I would
Okay.
probably
So
probably prioritize that over user profile and the number of questions solved.
okay. So maybe we can
Yeah.
toss this one out and then go for the
Yeah.
contest. Okay. So the non-functional. Okay. So let's see. Okay. So we probably want to have some kind of like a fast search when they search for a problem. Um, so fast search for a problem.
Mm-hmm.
So yeah, basically they can do some stuff and we can get a fast search.
Mm-hmm.
Um, and then we want to also kind of quick. Well, I guess we want to be able to handle. I guess maybe for the contest, we want to be able to. So I know at least roughly on LeetCode because I've seen people do contests. The contest page is actually not very up to date. Like it might take you might like submit some stuff and then go click on the page. It might even take like a minute to update to like the
Mm-hmm.
freshest stuff. So
Mm-hmm.
what do we want there? Do we want like really fast page updates? Because I feel like as like from a product perspective,
Mm-hmm.
I don't think it matters too much. Like if I go submit, especially if I'm not submitting the last problem, I don't really care like where I rank instantly.
Mm-hmm.
And maybe the last problem I do care, but also if I have to wait like 30 seconds because like the final update, like there's a lot of problems that are pending and all this other stuff.
Mm-hmm.
Even if it shows something right away, it's not going to be like the true update anyway.
Mm-hmm.
So I feel like for this, it doesn't have to be super performant. So are we okay with having like, like a 1 minute wait or something or 30-second wait for an updated contest page?
Yeah.
Does that
I
seem
think that makes
reasonable?
sense. Yep.
Okay. Okay, so contest page, eventually consistent, but not
Mm-hmm.
too fast.
Mm-hmm.
Yeah, and then list of problems, problem statement. Yeah, so I guess that's going to be like kind of like maybe the whole contest page, just like the overall site. So overall site, eventually consistent. Like this isn't like a trading platform or some kind of bank or anything. So as long as it updates eventually, then it seems fine to me.
Mm-hmm.
And then let's see if we have anything else. Yeah, I mean, I guess the other thing is just handle high traffic, obviously. Like, so yeah, we're just gonna assume we have a lot of users that are putting in code a lot. So we
Mm-hmm.
want to make sure, like that when they put in code and submit, we can run their code quickly and get their results quickly. So handle high traffic, return code results quickly, and things like that.
Mm-hmm.
So it doesn't have to wait too long. Like if they submit their code, it doesn't take too long because that part is kind of important.
Yeah.
The contest, the refreshing, whatever, but then the code running needs to be pretty good. So, let's say there's like a 3-second requirement, you should return the answer in like 4 seconds or something.
Mm-hmm.
Does that seem pretty good?
Yeah. That makes sense. Um,
Okay.
Couple questions quickly. So for fast search, would would you be able to quantify that, or like what do you mean exactly by fast search?
Yeah, so
Like,
actually, I
oh, go ahead.
guess here we can clarify. So I know on LeetCode, there's around 3,000 problems. For
Mm-hmm.
our site, how many problems roughly are we going to have here?
Let's just say 3,000 as well.
Okay, so in this case, this is basically taken care of automatically. Like, I don't think we need to build in anything extra, even if we do a full table scan or whatever.
Mm-hmm.
Doesn't really matter because we only have 3,000 items. So essentially, this is basically just like done right away because of the problem size or 3,000. Does that make sense? Like
Mm-hmm.
we can do whatever search we want. It doesn't really matter if we only have 3,000 items. We don't need to worry about adding like Elasticsearch or like whatever, any of that kind of stuff.
I see. That makes sense. And by
Okay.
fast, like how fast were you thinking?
I'm thinking the search would be like, you know, if you type in something and hit enter, I'm thinking it would be under a second.
Mm-hmm.
So maybe like 400 ms or something.
Yeah.
Like I think, yeah, because we have such a small data set, I think it'd be pretty fast. And if we notice that like the text search is a little bit too slow, we can do some small optimizations to make it. Or if we get more problems later, we can do some small optimizations
Mm-hmm.
to make it faster. That shouldn't be too difficult. But we don't need to build like an extra service
Yeah.
around this essentially.
Okay. Yeah.
Like yeah.
Makes sense. So for the overall site consistency, um,
Yeah.
like why did you mention that again? Like why do we need the site to be eventually consistent?
Yeah, because like I guess we were mostly talking about the contest here, but we don't need for someone to see their contest rating, um, or not their contest rating, but their contest score. Like, so on the contest, there's going to be a page of like submittance times and like stuff like that, and like where you are. We
Mm-hmm.
don't need that to be accurate right away,
Mm-hmm.
because first of all, a user isn't looking at it all the time, and second of all, it's fine waiting because those results won't be um, accurate anyway, even if you get it right away. It's kind of like an election poll.
Mm-hmm.
Like even if they get something instantly, the election's still in progress. It's not done. They can change all the time.
Mm-hmm.
So it's not like they're not interacting with it really. It's not super important. So eventually we do want it to show the right thing, but we're not super concerned with it showing the right thing right away. And then we
Yeah.
can focus on availability essentially.
Okay, so you're saying that wanna we have a trade off here between consistency and availability, and you want to go with availability.
Exactly. Yeah.
Okay. Um, is there any other maybe non-functional requirements that are unique to this problem because we're sort of like running code that someone
Yeah.
wrote?
Yeah. So I guess another one. So running code is dangerous, I guess.
Mm-hmm.
So we want to make sure to handle malicious code. Because like let's say their code is like remove all your files or mine crypto on your computer or like infinite loop or whatever. So we want to handle malicious code and also handle like you know endless loops or something like
Yeah.
that, right? We don't want to just like if they just send like a wild true, we don't want our stuff to hang. We want it to have like timeouts or something like that.
Nice. Yeah, I think that's a good set of non-functional requirements.
Okay. So I guess the next thing I'm gonna do, so I'm gonna try to kind of do the hello interview format. I guess you're familiar with it as well. I think
Mm-hmm.
it's pretty solid. Yeah. So
Sure.
the next part, I guess, what we can do is we can have the I forgot if it was the core entities or the APIs. I guess we'll go for the core entities and just keep them kind of basic.
Mm-hmm.
So the core entities here. So I guess we need to have, yeah, like a user. So the user is just gonna have like I don't know a bunch of user information. We don't. We're gonna as we go later, we'll add some detail there, and then we're gonna have a problem, and then we're gonna have a contest. And so yeah, just briefly, problem is just gonna have like a bunch of problem information. Contest is gonna have like uh, some contest information, and then we might want to have a table that joins users to contests. So we'll have like a user entry in contest or whatever it is,
Mm-hmm.
something like that, right? So we can see like what problems they, or actually, I guess here we can have, instead of having that, we can have like user submissions here, or problem submissions. Uh,
Okay.
so this can tie the user to contests and problems and things like that. Problem submission will essentially have like a user ID, problem ID, submission times, and stuff like that, and like some other data. I think that's basically all we need here. Does that seem pretty reasonable?
Mm-hmm. Yeah, I think this captures the tables that we need.
Okay. And then the APIs. So yeah, I guess we can go through our functional requirements and then we can just basically make APIs for them. So list of problems someone can search and filter by difficulty. So essentially, we basically need a get here where someone puts in, yeah, I guess just like a bunch of query frames essentially. So they can put in like a string, difficulty, all that stuff. So this can be like problems. And then they can have a bunch of query params here. So it can be like text equals something, and then difficulty something. And these can be optional query params.
Mm-hmm.
And then the type of the problem, like array or whatever it is, can be a query param as well.
Yep.
Okay, so let's see. text something, difficulty something. Okay. And then this will return. So we don't want to return. So for a problem, we're going to have a bunch of information, right? We're going to have like the full problem description somewhere, some other stuff. We don't really need that. All we really need is a way for them to click on a problem. So we're just going to return like a partial problem, which is just like the essential things we need here. So maybe like problem name, problem ID, some small thing, just so we can
Mm-hmm.
keep it small.
Sure.
Does that make sense?
Yeah.
And then we can add can also add pagination here. So maybe they can specify and also in the query params, like a what's it called? Like a limit and a start
Mm-hmm.
whatever that thing's called. Yes, it's like start problem or something. So we can
Mm-hmm.
add pagination, then they can click all the results. All
Mm-hmm.
right, so that should satisfy the first one. So display a problem with a problem statement. Okay, so this is going to be like a get problem with a problem ID, I guess. So problems, it's going to have an ID, and then that should give us the entire information for a problem. And I guess we need to figure out, maybe to keep it simple, let's just say problems only have like text. We don't need to worry about like some big images, or let's say the text isn't too big, we can just store it in like the problem metadata in the DB over here in this core entities. So we'll just return the full problem here.
Sure.
Yeah.
Okay.
Okay. Let's see. So display problem lets us send us code and get a result. Okay, so we want to be able to send code for a problem ID and get a result. Okay, so I guess this will be a put, and we can go like problems, and we send it to an ID. And then, so essentially this code will be like whatever we want, like JSON or whatever. We'll also assume it's not going to be super big. So they'll do a put, and then here they're going to get a result. So we're going to get like a result. And so in this body will be uh, maybe like code, and then whatever this format is.
Mm-hmm.
Not going to write the format here, some kind of format. And then we'll have some. I think that's basically all. Like code, maybe like language, some other stuff, whatever. And then we don't want to send the. Yeah, we don't really want to send like a user ID here because then you can just do something like Postman, like user IDs. So we
Mm-hmm.
want to have the user ID in like the header here instead. So essentially, we essentially send the code language, they get some result like passed or failed or something.
Mm-hmm.
Does that seem good?
Oh wait, so put problems is how we do submissions, or is that updating problems?
Actually, sorry, it's not going to be a put, it's going to be a post. Yeah, post. Yeah, so this is how we do a submission. Yeah, so essentially we make a post over here. I'm trying to think if we need to make another. I think we probably need to do something like this: post problems ID, and then we need to have some other thing like submission or something, and then
Mm-hmm.
that would work. Submissions, something like that.
I
That's probably
see.
like a better RESTful endpoint.
I see. Because it seems like with the post there, it seems like it will post a problem instead of a submission.
Um, I guess the other way we could do it is we could do it this way. So we could have post submissions, and then here we could have the problem ID. That would be work as well.
Okay.
Does that
Yeah.
make more sense?
Yeah. I think that makes sense because it would be because usually the URL would be to the resource, which would be like to the problem or
Okay.
the submission. But
Okay.
and
Yeah.
then you were talking about user ID. Where are we gonna add that?
So I think you need to add it to the headers or use like a JWT or something like that. Because if you just throw in a user ID here, then these requests can get like intercepted, and then people can just call these requests and put in user IDs.
Mm-hmm.
So we don't want to have it like in the body of the request.
But it also in the header they could fake it too, the user ID.
Um, yeah, I guess that's true. Yeah, I guess so. You'd probably want to have like a JWT. I don't know where the JWT is stored in the request exactly,
Mm-hmm.
or like a session token. I'm also like not 100% sure where those are stored in the request.
Mm-hmm.
I want to say it's just like a separate field in the request. Like there's a rec JWT or whatever it is, and then this is encoded. So like even if they, I'm trying to think like, can someone just like take that? I want to
Yeah.
say no, because
Usually,
I don't think this should be available in a request. Like you can't just like view it.
yeah. Usually it'd be you just use like the auth header, but with the session ID, the backend maintains the session. So it'll when you pass in the session ID, it'll be able to figure out the user ID in the backend based on your session. And the session is like a randomly generated like UUID. That makes
Yeah,
sense.
that makes sense. Yeah,
Cool.
so I don't think these are interceptable. Definitely need to do a little bit more work there. I don't really do auth stuff very much, so.
Yeah, I could explain it to you later on a different one because I think I get asked like that's one thing people bring up in interviews for sure is
Hmm.
where should like how should we make sure because if you just add the user ID there, right? You
No, I
could
definitely
post
don't
on
want to
behalf
do
of
that.
someone.
Yeah.
Yeah.
Yeah, that makes sense. Okay. So then, yeah, so I guess we want to also handle contests. So we want to be able to get the contest page. And then I think this post problem will handle, like this post problem will let them run we'll let them put in a submission and then we'll return to them a result. But also if it's part of a contest, we can have like a contest ID or something in here. So this endpoint will handle both of those, like submitting problems and submitting prompts for contests, and then that way we can have that updated.
Okay.
So here for this contest, so yeah, basically we just want to do like a get contest with an ID, right? Yes. So I think this will basically just give us the results page for a contest ID. So results for contest with that ID. Okay, and then we could talk about like what we need to actually get all that because we need to basically combine a bunch of tables here to do that.
Mm-hmm. Makes sense.
Okay, so I think that's all our requirements. So I guess we can move on to just like a design, like a simple design to have all of this, and then we can figure out like if something breaks, where does it break and things like that.
Yep. Works for me.
I'll make this a little bit smaller. Okay, I'm just going to write it on the right so I can ideally have my requirements here as well. Okay, so we'll just say we'll have some client. In this case, like LeetCode isn't like a mobile app or anything, so uh, basically, yeah, we'll just say we'll have some client abstracted away if it's like mobile or web or whatever.
Mm-hmm.
Okay. And then, oops, client. Okay, and move this over here. All right, then move that. Okay, so once we have a client, like I guess what things do we need? So we need something to run problems, and we probably want that to be like a separate service. So we'll have an API gateway over here. That's just going to handle like sending things to the right service and like rate limiting and all that stuff.
Mm-hmm.
So the client will call the API gateway. And then I guess we can have two services. So we can have a service for like the actual, like if you think about it, like how LeetCode is designed, one service will be the one to like give users all of their stuff for the client, and then another one, or I guess not all their stuff for the client, but like show problems, show contests, that kind of stuff. I don't know
Mm-hmm.
what that would be called. And then we'll have another service that will like run problems and get results.
Mm-hmm.
So this will be like the problem solver or something.
Sure.
And then another one here will be the, yeah, I don't know, like prob or just everything else. I don't know
Or
what
like a
like the
simple
best name would be.
CRUD service. And
Yeah, so like CRUD service, sure. Okay.
why do you want to
So
separate those out? Just want to get a sense of your rationale.
yeah, so basically, I mean, the main reason is just so we could scale them independently.
Mm-hmm.
So if we need to figure out like we actually are running a lot of problems, especially this problem service might take a long time. Like imagine a user does like a one-to-one of like getting problems and then submitting problems.
Mm-hmm.
The submitting problems, like the getting problems will be really fast, but submitting problems might take like 5 seconds for the request to finish. So this is going to be pretty like assuming like this is one-to-one usage or even close to that, the problem solver is going to need to get scaled a lot higher than the CRUD
Mm-hmm.
service.
Makes sense.
Okay, so centrally we'll have some stuff here. Oops. Okay, can I make the double arrow in here somewhere? I think so. I don't know where it is. Okay, well I'm just going to pretend all the arrows are double
Yeah,
arrows.
I understand. Like it's gonna
Okay.
eventually respond.
Yeah. And then we'll just have a shared database for now. If we need to have separate ones, we can do that. And I guess the upside of a shared is easier to manage. The downside is scaling. So you can go super crazy and like every request has its own database or every service has its own database and keep breaking down these services. But then, yeah, like there's, I guess, upsides and downsides. So we'll keep it simple for now and then change it if we need to.
Sure.
So I'll have DB here. The CRUD service will call the DB. The problem solver will call the DB. And then, yeah, so we can quickly talk about these tables in a little bit more detail. So a user is just going to have like a user ID, and then user metadata. I don't think that's super important. So just a bunch of fields about the user. Okay. And then what other stuff? I guess I can copy these over and
Maybe let's
talk about
bring
this.
them up in terms of the flow. So, for example, I just want to get a sense of like how somebody gets a problem or gets a list
Okay,
of
yeah, sure.
problems, and then we could build out the database along with the
Okay, yeah, sounds
request and
good.
response flow.
Okay, yeah. So the client is gonna query for, yeah, I don't know where you want me to write this like list of problems, but essentially the client's gonna, I'll just talk about it
Yep,
instead
sure.
of like writing these. So client's gonna query the API gateway with this get request for a list of problems that they're gonna have a search string and then some other stuff.
Mm-hmm.
It's gonna call our CRUD service, and then it's gonna call our DB with all our problems, and then we
Sure.
can basically just do a full table scan because it's only like 3,000. That's like really small, so it should be really fast on their field. So essentially, yeah, I guess we can add the problem now.
Mm-hmm.
So the problem will have like a difficulty that they can provide, category, name, ID. I guess ID will be first. Yeah, some other stuff as well, like problem metadata, with that we don't need to return. That's what we're returning the partial thing, because the
Mm-hmm.
metadata is going to be the one that's going to be like most of the data for this thing. Like, all these other things might be like a word, and then the metadata might be like 200 words,
Mm-hmm.
or the actual like problem description, we'll call it, I guess. Description. And then, yeah, I guess I didn't mention this, but I guess we'll keep adding problems and like removing problems out of scope. We'll just assume they're there.
Yep, yep,
Um,
for sure.
okay. Yeah, so that's basically what it's going to look like. Is they're going to call a CRUD service, going to get DB, get back a list of problems that don't have the metadata, and then we'll just display that on the client with some pagination. Yeah, I guess we'll have pagination here as well. So yeah, something like that for the list of problems. Does that one make sense?
Yep.
Okay. And then, okay, so this problem with a problem statement to the user. So what that's going to look like in the UI is they'll have a list of problems. They click on a problem. Then when they click on the problem, the client will make a request to the CRUD service. It will get the problem with that problem ID, and then it will get all of this information for the problem now, and then it will display that to the user.
Mm-hmm.
So yeah, and then they can basically like type in code and whatever.
Okay.
Um, I guess also to keep it simple, I'm not going to worry about things like, so let's say in LeetCode you type code and you like go away. We're not going to like save their code. Uh, we'll just say like if they submit, we'll do a submit, and all of their code will never get saved. So if they refresh the page, we'll just say the code is gone. We can
Mm-hmm.
add that as well if you think that's important, but I'm just gonna keep it simple for
Yeah,
now.
we don't want to store it in the database. Or you're saying you don't want to store what the current state in the database?
Yeah, like their
Yeah.
code. So essentially, if I like in actual LeetCode, if I type some code and I refresh the page, that code stays because we're saving it in the
Mm-hmm.
database, I think. But we're not gonna do that in our service just to keep it simple. Like that wasn't one of our features.
Mm-hmm. Is there
Okay.
any way we could kind of do that simply without storing it in a database?
I think we can store it on the client. Would be the other way. So if they refresh, so we can store it in like local storage or something. I don't know how much
Mm-hmm.
you can store, and I don't know what happens if they solve a bunch of problems and it's all stored in local storage. Like I don't know if there's like a limit or like how big that is. But yeah, we can just store it in the client side, like client side local storage or something like that. And then we can just look like, do they have something stored here? And if they do, we'll repopulate.
Yeah, makes sense. Yeah, I think they do some sort of local storage, but yeah, not sure either. But yeah, it's a good
Okay.
point that we could store it client side or in the database.
Yeah. Okay. So let's say they get this problem, then they submit a solution,
Mm-hmm.
and now the problem solver. So this part can't just be a regular server because yeah, we have all these malicious things. So I think the way to handle this is one of two ways that I haven't personally used, but I'm a little bit familiar with.
Mm-hmm.
I think you can have like an AWS Lambda, which is like, or like a virtual machine, which is going to be like self-contained, or you can use containers.
Mm-hmm.
So I think we can maybe go with containers, because essentially for a container, we can say like, so in this problem solver, we can have containers. And we can provide to these containers. So we want to provide kind of like a real LeetCode problem. We want to provide CPU, like allocate, like how much CPU are we providing, memory, and then duration.
Mm-hmm.
So that way, if they have a while true, it'll just time out.
Sure.
And yeah, I'm not going to talk about like, I guess, in detail container making, because A, I don't know that too well, and B, I don't think it's like super relevant.
Yeah.
But the other things we also need is we need to make sure to like disable malicious things.
And like one thing I would say is if you're doing a more product focused role, that'd be fine. And then what I heard for the more system focused role, they might actually ask you a little bit about the containers because they can't like the infrastructure side roles. They might
Yeah,
go a bit deeper
absolutely.
in
Makes
that.
sense. Yeah. I'm definitely, yeah. I mean, at my job, I'm doing product, so I do think I have a better understanding of like product and client and like client experience in that than like the infra. So yeah.
Yeah, that makes sense. Yeah, we'll
Okay.
keep it product
So
focused then.
yeah. So disable malicious things would be like access to files, so they can't like delete files, and then I
Mm-hmm.
think network requests are like the two that I'm thinking of. So
Mm-hmm.
we don't want to just like, I think those are like the two main ones. And then because this is not like these containers are separate, they won't be able to like do stuff on our server anyway,
Mm-hmm.
because they're like separately spun up. So
Mm-hmm.
as long as they can't access the files and make network requests, then those would be like the two problematic things, right?
Yeah.
Maybe there's some more stuff there, but I think for the most part that could be pretty good.
So you're saying they're isolated from the host here, these containers?
Yeah, exactly. So this problem solver service is just going to spin up containers that are isolated. So that
Mm-hmm.
way the malicious stuff is like less likely to happen. And I think you can also, like, at least I've read about it, you can also do things like disable access to files and network requests. I don't know if you do that in the container build or like, yeah, I don't know exactly where you do that, but I know this is like a thing you can do.
Mm-hmm. Makes sense. And just a question: this problem server, it's one server has different containers. Like it's a strong server that hosts a ton of containers, or how are we thinking
Yeah, so
setting
for
it up?
now we're just going to keep it simple, and then we'll talk about scaling
Sure.
afterwards, I
Okay,
guess.
that makes sense.
So these containers will be so I guess there's two options for containers we can have. Um, Maybe make this problem thing bigger. So one option is, let's make this smaller. Okay, so one option is we can reuse the same container here. So essentially, what would happen is like, let's say one one thing of code is done, um, and then we can. So yeah, I guess we can like, I'll write this down. So we can reuse same container, where we just leave it on, and then the other option will be you respin it up. And the upside of reusing is basically, yeah, so let's say someone submits some Java code, it'll run it on our Java container. Then when that's done, someone commits some more Java code, it'll run it on our Java container, and the container is like always active.
Mm-hmm.
Um, the downside is if we do that, is we need to have a container for like every language, because like in LeetCode, there might be like 20 languages. So let's say um, they're submitting like Scala or some weird, or who knows, whatever, super rarely. Like you
Mm-hmm.
might get like 100 times the Java. If you just have the same container, it's kind of hard to like. First, why would you want to reuse a container that's basically never used? And then also the ones that are used, like how do you use that more? And then the other thing we can do is we can respin up a container every time we need one for a particular problem. And the downside there is I think it's longer to like spin it up than to like use an active one. So this would make it like take longer, but it can also scale better. And I guess we can have like a hybrid approach where maybe we reuse common language containers. So for example, like you take the most common languages that people submit in, like Java, Python, C++, we reuse those. And then for the rare ones, um, spin up when needed. Does that kind of make sense? So we have some hybrid approach, and then we could talk about like scaling the containers and all that stuff later as well, like how many we need and all that stuff.
Yeah, that makes sense. What you're describing here.
Okay. So let me just make sure we have everything here. Okay, so we have the submit problem. Now I need the contests. Yeah, so let's just so we'll just say the contests are just like created somewhere outside of the scope, and then we can just access them.
Mhm.
So maybe like some
Actually,
admin or
I have a quick
something.
follow up here.
Yep.
Could we just quickly talk about the client server or like the whole interaction of like submitting a question?
Oh yeah, yeah. So when you submit a question, it's gonna go to the problem solver.
Mm-hmm.
It's gonna send this request of like post of code, language, problem ID, contest ID that might be null.
Mm-hmm.
So I guess we can talk about the submission in the database. So it'll have like user ID or no, actually we don't want the user ID, right? I talked about that. So we don't want user ID. We want like problem ID, like code in some format, language, some other stuff, some metadata, whatever. So when they make a submission, it's going to go to our problem solver depending on the language. It's going to run a container depending on the language, and then it will either return like true or false because we're going to have test cases,
Mm-hmm.
or it will time out, in which case it will just auto return false. So like if the container, if it's like too much memory or too much CPU or the duration or whatever, we will just basically time out.
Mm-hmm.
And I think you can just do this by having like each problem might have like test cases or something we can pull up in the container and then just run it against those test cases.
Mm-hmm.
So once we get a result, then we just essentially we probably want to store it in the DB as well. So once we run it in the container, we want to store the result in the DB, like did it fail, whatever, some metadata, and then return that thing to the user.
Mm-hmm.
Does that make sense, or did I miss something?
Yeah, no, that makes sense. So, just curious, like, is the client just gonna wait for this thing to finish, or is it gonna be something async? Like, is
Hmm,
it gonna poll?
I see. So, hmm, I wonder what this will be. I think we can wait. Yeah, so I think we can just basically wait for the request to finish. So yeah, I think just going off of LeetCode or I guess like practical design. So if it polls or something async, it doesn't. It's kind of weird. Like I don't want to submit and then be doing like a bunch of other stuff and then all of a sudden I get some random result. Like I want to submit and then maybe like the button spins showing that it's like doing something,
Mm-hmm.
and then and then I just get a result. So I think the client can just wait. I want
Mm-hmm.
to say we can do some polling, but I think waiting's good because I don't know. Maybe some languages take a while, but I think we should get a response back within, let's call it 5 seconds. That's not too
Mm-hmm.
bad. And
Yeah,
usually when they submit, they're basically like a user experience going to be like they're going to submit. They're not going to want to do anything else. They're literally just going to wait and see like what happened before doing anything else.
yeah.
They're
Okay,
not going to like submit a problem and then go read the description again or something.
I see.
So I think
Yeah,
waiting's okay.
I think yeah, that rationale makes sense because it is because I was more thinking about like what if it takes 5 minutes to run all the test cases. And I'm not really worried about like more. What I'm worried about is the infrastructure hanging up the connection if it runs too long. I think it's in API gateway. It's like
Yeah, I
a
mean,
one
we can
minute.
we can we can we can just set timeouts on the requests, I think, right? So you can just say, if there's something hanging, will return nothing. Or we can probably even set a timeout in the like you're saying if like the server crashes or something like that.
Yeah, like what if it takes a minute to run, right? And all of a sudden it just gets hung up and it has to retry
I see.
that same test case. The client started an HTTP request, right? And is waiting on
Hmm.
the server. And then the server is doing work for too long. At some point, some of these start getting hung up depending on the infrastructure. Like they start hanging up the
Hmm.
connection. You'll see that sometimes with long running HTTP requests. Is there any
Hmm.
way we could solve that problem?
So I think the minute would never like so let's say a request. So like in this container, like we're gonna give it some time, and the time we're gonna give it is never gonna be more than like we'll call it 5 seconds or 10 seconds or something. So I don't know how it can get to a minute because like basically the container would just or like this would just time out in the
Mm-hmm.
server and then would get something back. So I don't think that can happen. Yeah, I mean, obviously, if it's like overloaded with requests, then there might be something that goes on there.
Mm-hmm.
But we can also set a client side. We can set a client side timeout, right? Like we can just do a fetch and then just set like a. If we don't get anything 10 seconds, then just like throw an error on the client side and like tell them to try again or something.
Mm-hmm. Makes
Like
sense.
that would also be fine.
Okay. Yeah. One
Yeah,
thing
I
I
know from.
or go
Or go
ahead.
ahead.
Or you
Yeah, I
you
was
go ahead.
gonna say I know from working on like we do have some requests that do a lot at Blend, and so you might call a request, and it actually does take like I wrote something recently that takes quite a while, like 20, 30 seconds, but it's
Mm-hmm.
like their user experience is they're just waiting for this thing anyway, so it doesn't really matter. And then yeah, basically if it hangs up after a while, then yeah, you just throw an error essentially. You
Mm-hmm.
could also like poll, I guess, so you can keep polling for like, is this submission solved? Is this like basically what we could do is in the problem solver, we can store in the DB the status,
Mm-hmm.
and then we can just poll from the client and check like, is it done? Is it done? Is it done? Something like that.
Mm-hmm.
That'd be another way.
Nice. Yeah. Yeah. I was just curious if yeah, what other options there were.
Okay.
One
Yeah.
thing I wanted to really get into is like handling surges as well. I guess we
Okay. Yeah.
missed it. We kind of missed in the non-functional requirements, but imagine the contest is about to end and everyone or it just started. People are spamming submissions. How are we gonna handle these large surges in submissions?
Right. So I guess I was going to talk about that like after we have our simple functionality.
Mm-hmm.
So yeah, I guess did I talk about how we get contest data? I mean, it would be kind of similar. It would also be like the client calls a CRUD service, and then yeah, it'd be kind of similar.
Yeah.
And then with the contest, it gets that. Okay, so let's say yeah, so let's say we have a surge. So then what we want to do is we want to be able to scale. And I guess what's the thing we're going to be scaling? So
Mm-hmm.
yeah, it's going to be these submissions, right? I think that's like going to be the point of breaking is if there's a lot of fetches, it's not nearly as bad as submissions because submissions take like way longer. So
Mm-hmm.
what we can do is we can scale this problem solver dude. Like
Mm-hmm.
we can just horizontally scale here, this service. Depending on, we can scale, yeah, so I guess if the containers are spun up within each one of these like instances, we can just basically horizontally scale this problem solver. And then we can just, yeah, essentially if we scale this, we'll have more containers. And then we can also figure out, like, so I said we can have like one container for each language. Realistically, we can try to figure out, get metrics on like what languages are more popular and have those like be, have those have like way more containers. So, so maybe for like Java, we might have like 20 running containers or something. Um,
Mm-hmm.
and then for some other stuff, we might have like one or two. So that could be another way we could handle it. Is we have everything spun up, but for the languages no one ever uses, we'll have like one or two. And for the bigger languages, we'll just have a lot. So essentially, we can basically scale every language independently, and we can also scale this entire problem solver service
Mm-hmm.
when needed. We can also figure out like with doing just like product data stuff. Um, we can know like, okay, well, we have a contest once a week, let's say, and this contest ends at this time. So we can say like, A, during the contest, scale this like compared to
Mm-hmm.
normal because we're going to have more traffic. And B, if you want to be more precise, close to the end of the contest, scale it because that's when more likely you're going to have more submissions. So that's another thing is you can have metrics and then have more accurate scaling
Nice.
um, to just like save money.
Mm. Makes sense. So, while this thing is in the process, or I just also want to understand one thing is like when someone submits, I don't want that submission to get dropped, right?
Okay.
So if a submission comes in and all of our servers are in the middle or we're in the middle of horizontally scaling it, we don't support enough at the moment. Like, how can we ensure that submissions don't get dropped?
Okay. So I think the way LeetCode handles this, I've seen at least, is if we do have a problem, we basically just have a client side problem. But if you want to not do that, so that's one way. Like submissions will get dropped, but they'll get notified right away. So essentially, you hit submit, you just get an error right away, like uh, you know, try again, or not right away, but within your timeout. You set a timeout after 5 to 10 seconds, it'll just say like retry, and then you reload and retry. If
Mm-hmm.
you don't want to do that, then essentially what we need to do is, I'm trying to think like what would happen. Like if it gets dropped, we need to have some kind of retry mechanism.
Mhm.
But also, if it's a mission, like let's say you make this request and our infrastructure has some problem, I think this request will break essentially, right? And then like you need to basically do something else again. So like let's say I submit a problem, this thing crashes or whatever. This request will error out, and then you're saying like how do we still like do a submission after that? I'm a
Yep.
little bit confused there, I
Or
guess.
or like pretend we get a surge in traffic and we didn't expect that surge, so we don't have enough systems to scale it.
Uh-huh.
Every like we don't want to just send 500s to everyone at that point, I think. I
I
feel like
see.
there's a
Okay.
way that we can build the system so that
I see. I see.
when
Okay.
it scales, it might take a longer to respond, but we not a bunch of people aren't just getting 500s because that would be a weird experience too, right? We might be like, oh, our servers are taking a little longer, but it's like you're gonna get your result in a sec.
Yes. Okay. So then I think they're not as familiar with this, but I think we can just have like Kafka here, I guess,
Mm-hmm.
where anytime you um, anytime you make a submission, it will go on Kafka, and it can be like indexed by like the problem or whatever. We can figure that out. But essentially, we're gonna have the requests on here, like these submissions, and then it's gonna call our server. Um, and then even if it fails, I'm trying to think of like how we can have a retry mechanism. I mean, you can just have like an async service with a retry mechanism essentially. So you can put in a retry mechanism in here, so it'll like get the topic, and then or maybe even yeah. I'm trying to make sure how we could do it like 100% not failed. Yeah, I guess we can have like Kafka here, and then we can get the submission. And then in our problem solver, we can check like, was this solved? Did we return something? And if we did, then we can just like stop. And if we didn't, then we'll like try again. But essentially, yeah, you can build some kind of retry mechanism in here where like if it does get dropped, we can have the topic available on Kafka. Um,
Mm-hmm.
yeah, look, once again, I'm not like super sure in the implementation here of like if you get a topic, can you get it again, or can you make sure that like essentially the flow we're going to need is like get a topic, solve it, or sorry, make sure it's solved, and then if something broke, then we can like get it again. I don't know if like Kafka
Mm-hmm.
supports that, but we would want to have something like that. There's probably like a better solution here.
Mm-hmm.
But even if that's the case, then like how do we return that back to the user? Like on the user experience will be like they'll submit something. Um, the request will yeah, I think if you just have like a surge of requests, like eventually some get dropped.
Mm-hmm.
So yeah, I guess like maybe I'm not super sure how we can make this better, but I'm thinking something like this. Put the requests on a message queue, and then we can run them. Like we can at least try to run them for sure. So what would happen here is like let's say we have a bunch of requests. Some might not even start to get running because we just have like a blockage here, right? Like if we have a surge, like some requests might not even start. So at least this ensures all requests at least get started once. And I think that actually might work.
Yeah. Like I like the queue approach because also one thing to consider is like pretend we give a container a problem to solve or a
Uh-huh.
server a problem to solve and there's an infrastructure issue there.
Hmm.
If that server fails, a different server will still be able to like look at the queue and see that it hasn't been processed and then process it itself. Like a completely different server than the server that we sent the data to
Yeah,
run
that
the
makes
first
sense.
time.
So essentially we can get a topic, process it, and then like how do we move it off the queue or like
Mhm.
write that it was processed? Do we just put that in the DB?
Mhm. Yeah.
Like
Yeah.
that would be the main
I
concern.
yeah, that makes sense. Let's see.
Okay.
Yeah, we could probably talk about it after and when we're
Okay, yeah.
doing the summary.
Yeah, yeah, okay.
Let's see. What other things probably a couple more minutes and then we could go through.
The summary and like what are
Yeah.
the drawing stuff? Okay, sure. So I guess looking at the non-functional, so fast search, yeah, that's basically done. Site eventually consistent. So we're gonna have these submissions. I guess we didn't really talk about the site being eventually consistent. how would the site be eventually consistent versus not? So let's say we have this like rush of submissions. Um, yeah, basically, yeah, I guess the eventually consistent part there would be, um, so like this problem solver might be writing to the database a submission while the CRUD service is getting a contest, and so this might be like at the same time or something, but we're gonna allow that actually because it doesn't really matter. Like we can just it won't be the freshest, but it'll still be fine essentially. So we can read stale data and it'll be fine. And then like eventually when they like refresh the page for the contest, like let's say once the submissions are over or they wait long enough, then we'll have the new data. So I think we don't need anything extra. We would need something extra if we wanted like the freshest data possible, then we'd need some like more complicated stuff. But I think
Hmm.
that part is done as well. Then we handle the malicious code and all of that.
Yeah, that's good.
High traffic, handled that.
Yeah,
Yeah, I'm not seeing anything extra here that I would like to add. Maybe I missed some stuff,
yeah.
but yeah, I think this
Oh,
looks pretty good.
yeah. I think things is good, and we just hit the 51-minute mark. So yeah, I think we got through a lot. How do you feel about the interview, or like how you did and stuff?
I definitely feel like I don't know, like a lot of these things that you asked me, I don't know in enough detail. Like I definitely would want to explore more.
Hmm.
But I think overall I got something reasonable, but I think yeah, definitely need more practice. And I think this would be, like a lean no hire something type of thing if I had to guess, like, just barely fail type of thing. Like it wasn't too bad, but it can definitely be improved a lot.
Hmm. Let's see. I would say it's a higher, especially for the for the product focus. Like
Okay.
I'll probably give you my feedback quickly. Would be, yeah, I think a lot of the good things you did was like, yeah, you're really strong on the product perspective because yeah, you work on product all the time, so you understand the different things like subtle things that like people more on the infrastructure side might gloss over, which is yeah, like when you get a set of problems and you don't need to return all of the problems, just a partial problem, so that you could just show like a skeleton of them, and when they click into it, you get the full problem. I think I've seen
Hmm.
candidates miss that sometimes. Good job with the pagination as well, because yeah, um, just making sure that it's not fetching everything at once and just mentioning that.
Hmm.
And I think you did a really good job with the container talk of just setting different limits like the CPU, the memory duration, and disabling the malicious things. Yeah, that part was really good. Probably some of the things to work on was I think you went a little off topic for some of the features. Some of the feature, because what how I think about it is some of the like when you're given a system design problem, you want to solve things that are very unique to that problem. So for this, I think one of the very unique parts is like the security of running the code and like how are we gonna run the code.
Right.
Because I think you mentioned that we are gonna like show user profiles and stuff like that, and
Hmm.
it is like something we need to add, but I think like the CRUD operation part is not like being able to list problems and searching through problems and stuff. That part is already
Kind
like
of done, like pretty
yeah.
pretty simple, and it's like everywhere.
Yeah. So for example, what I've seen candidates do on stuff like this too is and I even do this too honestly in some of the where I go a bit off topic and in a very short interview it can cost you. So for example, with the list of problems, if you start talking about searching too long,
Hmm.
do you think that would be like a good use of time talking about like how we're gonna be able to search for problems in LeetCode?
No, no, no. Yeah,
Yeah.
I think it makes sense. Like try to find things that's common between every problems and just like take that for granted and then go into detail about the things that's unique about this one.
Yeah,
Yeah, it definitely
exactly.
makes sense.
That's like when I so for if for example I'm given, oh, let's design Ticketmaster, then I know the unique part is making sure we don't double book tickets, right? So if I spend all my
Yeah.
time talking about some of the crud services that are kind of like even the junior level folks are able to get, then I won't be able to
Yeah,
show
yeah,
my
yeah.
depth, right? So I
Yeah, it
think
makes
yeah.
sense. It's like, yeah, like if you're talking about like how do I list events or something, like that's everywhere, then who cares? Yeah, makes sense.
Hmm. Yeah. Let's see what else. Yeah, probably just look into a little bit about the authentication because it's pretty common
Oh
across
yeah,
all
okay.
of the problems of just like how we handle sessions.
Hmm.
And then let's see. Yeah, I think for the non-functional portion, definitely think about like super edge cases, and what that means is, for example, we're building LeetCode, right? That would be surges of edge case would be like, okay, we have a ton of surges, right?
Hmm.
And then for maybe like Instagram, right? What would be a super edge case would be like famous people, right? So think of like
Yeah,
super,
famous people make a post or something.
yeah, exactly. Where and that's also like surges because once a famous person posts, it has to like get sent to tons of people who are already subscribed to them, right?
Hmm.
So I think that's one part I also like forget about a lot, but I just make sure to bring up would be like the edge cases. Cause yeah, I think being able to the other ones you handled are really good, but then like the super edge case that might like make it a strong hire be like, okay, but yeah, we like you're thinking about like those edge cases, right?
Yeah, so I'm curious, how would you handle like the thing you were saying, where like the server crashed or something? Like, would you do basically this,
Yeah,
or
yeah.
did I miss something there?
No, yeah, definitely what you're getting on the right track. So one thing that I would just also mention is there's like difference between like message queues and or like using something versus Kafka versus something like have you heard of SQS?
Yeah, we use SQS.
Yeah. Um like Kafka is more like you can have multiple subscribers
Right.
listening to the Kafka queue. So
Yeah, I
it's
think
all
SQS is just like a queue. I think Kafka
yeah,
has like you can do more stuff. Yeah.
exactly. So Kafka pretend if I want to like capture data on Kafka and then I want to send it over to like six different consumers,
Hmm.
right? Versus something like SQS is just a simple first in first out queue, and its job is like one consumer is going to consume it, and if that consumer doesn't do it, like some consumer has to consume it, but no, like which one would you use in this case? Like, would you rather just have like a broadcasting type queue or like a simple FIFO?
Yeah, probably a broad. I want to say. Well, actually, so you're saying in SQS like one consumer, but like basically I just need any server that's available to consume it, right? I
Yeah.
don't care which one.
Hmm.
So in that case, I don't need to pick. So maybe SQS, I guess, if it's like the
Yeah.
first available one just takes it. Yeah,
Yeah,
makes sense.
because I wouldn't want like three people trying to solve the like running the test cases on
Oh, that's a good point.
right.
Yeah, you don't. Yeah, you don't want to have multiple. Yeah, that makes sense.
Yeah. So kind of what you could have here is let me zoom out a bit. It's like uh, let's do I'll just erase this quickly. Is yeah, having like a first like a FIFO queue like
Hmm.
SQS, FIFO queue, and then you could have different the FIFO queue. You could have different workers sort of consuming from the queue, the different
Hmm.
workers, and they could be like different runtimes and stuff. But essentially, what they're doing is just listening for the queue. They're not like Kafka is more they push it pushes changes to all of the subscribers, but these ones
I see. Yeah,
will be like fighting for the first element in that queue, and only one will get it. But imagine one shuts down, it's still stuck on that queue, and someone else will grab it, a completely different server,
makes sense.
right?
Yeah.
So like when we have surges, what we can do is actually look at our FIFO queue, and if the FIFO queue starts to grow really fast, we could add more servers, right? But
Hmm.
essentially, we won't drop requests because they're always going to be stuck in this FIFO queue, who's like
Pretty stable.
yeah, exactly. So
Makes sense.
we can that way we can horizontally that we and these FIFO queues you could already horizontally scale those as well. I mean Kafka's
Hmm.
horizontally scaled. So yeah, and we could a lot of companies you'll see them monitoring the health of the queues and stuff, and then they'll spin up services when the queues get too high.
Yeah, we actually have a SQS queue, and I'm actually working on like monitoring. I just haven't used it like at
I
all.
see.
So yep,
Yeah, but then
but really common. Yeah.
one thing that it adds as well too is that you need a server to like input into the FIFO queue as well. So there will probably be
Hmm.
like some server that it hits, and what it's gonna do is like put into the FIFO queue, but then also figure out the submission ID and status, like you mentioned.
Hmm.
And because now what happened here is this is the server. when you add it to the FIFO queue, like the FIFO queue can't respond to the client anymore, right?
Yep.
So what it's gonna do is it's gonna build the submission, and the submission is gonna have like a status of if it's
Yep.
done or not, and then it's gonna push it to the FIFO queue, and it's gonna tell the client to check up on that submission, and then
I
the
see.
client would poll for that submission because this server we shouldn't let this server wait because we don't know when it's gonna run, right?
Right. Okay. So we'd have to have polling instead then, basically, because we don't
Yeah,
know.
like
But the nice thing about this is, I guess, even if you have the server doesn't need to get scaled that much because all you're doing is basically just putting a request onto the queue. You're not actually like running the problem or anything like that.
exactly,
So makes sense.
exactly,
So
and
it's
it
super
doesn't
quick.
get dropped. Like the client is eventually gonna get the request,
hmm
or if the submission is eventually gonna run. Um, but yeah, that would be like one way to do it as well. And
And I
then
guess
yeah,
even if they like let's say you submit and then you go somewhere else, I guess when you go back to the problem, you can just look up like, does this user have a submission for this problem? And if yes, then have like a submitted or whatever, and have their code in there already.
yeah, exactly.
So that makes sense. Yeah.
Yeah,
Okay.
and then it will like like these will asynchronically like set the status
Yep. Yeah.
like
It
when
makes
it's done.
sense.
But yeah, I think that would be the only thing would just be like handling those surges and just understanding the difference between like something versus Kafka or when to use Kafka or SQS because
And
some
also
they
surges are
yeah
like common between every single system design thing, so I guess good to look
yeah
into. Yeah.
exactly. They're solved in different ways in some of the different ones, but this is pretty common of like building a message queue. So like in the
Right.
companies that I've worked at, if a request is gonna take over a minute, we're gonna make it poll instead.
You're gonna make it poll. Oh yeah, gotcha.
Yeah,
And then you put it on a queue. Okay. Yeah,
yeah,
we definitely use Kafka as well and SQS. I'm just not super familiar what we do with which. I haven't worked with it as much. So yeah.
hmm
Okay.
yeah,
I did make like I don't know if you heard of like temporal. I did use that. So it's like an async worker or an
yeah,
async request thing, and
yeah,
kind of has the same thing
yeah. That's
where
nice.
you
Like
just you run something async, you have a retry mechanism, and then yeah.
yeah,
Okay.
that's like because like what we're doing here is essentially we're doing a job schedule, right? Like what is the job that we're scheduling to run some code? Because we don't want to
Yeah.
run that synchronously. From the client
Yeah.
perspective, we could always have a loader and stuff. But
hmm
then I think yeah, we just need to think about what if that server we sent the code fails? How are we gonna run it again? Are we gonna have like one server watching over all the other servers? Like it gets complicated if we don't like use a queue. I think
No, that makes sense. Yep.
yeah,
Cool.
but yeah. Otherwise, no, that's a good job. Like from the product perspective, like you hit every part of it. Yeah. How do you feel now?
Mhm.
Like thinking about it. Or actually, I'll give another thing on the non-functional would just be um, quantifying it. So you said fast search, but what does fast search mean?
Yeah, it's a
So
good point.
yeah,
Yeah, numbers.
yeah. So like people say that
Yeah.
200 to 300 milliseconds is like fast for the human eye. So usually
Right.
you want to quantify it. Like what's high traffic and like 5 million users and surges.
Yeah, that
Like
makes sense. Yeah.
just
So
quantifying stuff
yeah.
because eventually I don't really do back of the napkin estimations because I
hmm
never yeah I just never got to it. But like if you want to do the back of the envelope estimations, you're gonna have to have quantifiable numbers on the non-functional requirements here too.
Yeah, I guess I don't really do it until I need to figure out if I need to scale something. So like
Hmm.
for the DB, for example, I'll just say like we'll use one DB. And then if I need to figure out do we need to scale the DB, then I start trying to estimate like how much data we have, and then
Hmm.
like do we need to scale the DB? So I guess yeah, don't do it right away, but eventually if you need to think about like yeah, like maybe this part, right? Like do I need a queue? Do I like put in some numbers and then try to figure out okay, what are the numbers I can handle just like normally? And then what are the numbers I need to make a more complicated solution for? And then like know what those numbers are. Makes
Hmm.
sense.
Nice. Yeah. So what are your thoughts on the whole thing? We should do it again for a different question.
No,
That
yeah,
was
I
fun.
think if I do more, I mean, I think it's definitely an interesting topic, and yeah, so and I think yeah, definitely interesting to get into, and I can take this feedback and then do some more.
Nice.
Um, and yeah, I definitely did feel like, and I had this before in actual like system design interviews where I was kind of like stuck, and I think this is the area where I was stuck. The like the how do you handle high traffic?
Hmm.
So definitely good to figure these out. Plus, also I think mocks are just super valuable because in this market, like if you are interviewing, especially for big companies, you might have like a couple a year. So it's like, well, if you have a couple a year but you do like 20 mocks, that's better than like doing a couple and then like failing and then like learning off of that, you know?
Yeah.
So,
And you never
yeah.
get real feedback from
Yeah, you
failing,
never get real
honestly.
feedback. They're just like, well, you just didn't do well enough, or
Yeah.
well, yeah. So that's the other thing is, yeah, you don't get any feedback. So definitely super valuable.
Yeah. Like some of the feedback I've got when I failed is like I didn't get into enough depth, and I think the reason why is because I started focusing on parts of the problem that weren't that interesting to the problem, like like listing out all the CRUD operations across, like what I mentioned earlier of like not thinking about what like the interesting part of the question is and getting to that faster.
Yeah, I think I was watching some on Interviewing IO, and there was like a extreme example of like what not to do almost, where the guy just like started dropping every single thing you can use and just like started going into like, okay, how do we handle the login page? And I'm just like, dude, if you keep doing this, like in 30 minutes, you will literally have nothing. And then the guy interviewing him had to be like, all right, step by step, here's what, this is like
Yeah,
completely off topic.
yeah.
So it's good
You
to see this like
definitely,
extreme example of like what not to do.
yeah, you definitely weren't like that. Like you had really good structure. That's why like definitely like a pass, especially on the product
Hmm.
side. But if for the infrastructure side, I'll be looking for like some of the other infrastructure stuff that we were talking about for the feedback. But
Makes sense. Yep.
yeah, awesome, cool. I'm gonna probably stop the video here.
Okay, great.